In this video, we will be examining how epistasis affects the phenotypes that result from two different crosses in relation to fur patterning in cats. There are three different phenotypes involved in this pathway: no fur pattern, spotted, and striped. There is an enzyme A that turns a patternless fur into spotted fur, and enzyme B that turns spotted into striped fur. We are specifically examining recessive epistasis, so the existence of a dominant A allele at the first locus codes for spotted fur, and dominant B allele at the second locus codes for striped fur. For the striped phenotype to be present, both loci must contain the dominant allele, since spotting is epistatic to striping. When we perform our dihybrid cross between two heterozygous striped cats, the results of the potential offspring are shown in the Punnett square. We are going to use red to indicate which offspring will exhibit spotted phenotype and green to exhibit striped. Since we are examining recessive epistasis, the ratio is 9:3:4 as we would expect. The 9 striped cats we saw on our Punnett square had to be dominant for both the A and B alleles so that the respective enzymes could function correctly to produce striped phenotype. The 3 spotted cats that we then observed are going to be dominant for the A allele, but not for the B allele, since a homozygous recessive genotype at the B locus acts as inhibitor of the B enzyme that codes for stripes. The remaining 4 cats that show no patterning are homozygous recessive at the A locus, and the activity of the A enzyme is inhibited. Thus, there are going to be no patterned cats. It does not matter what the genotype is at the B locus, since the A locus is epistatic and its alleles mask the B alleles when inhibited. Now, instead of performing the normal dihybrid cross that results in the 9:3:4 ratio for recessive epistasis, we will be performing a cross between a spotted and patternless cat. From this cross, we observe 4 potential offspring that are spotted, 4 that are striped, and 8 that have no patterning. We will still be following the rule for recessive epistasis in that the dominant allele must be present in order to advance across the pathway. Like the pathway we observed earlier, the 4 striped offspring are a result of both locus A and B being dominant for their respective alleles. However, since this was not a dihybrid cross, the only dominant genotype is heterozygous and no homozygous dominant alleles were present at the 2 loci. The 4 spotted cats have the production of the B enzyme inhibited due to the presence of the homozygous recessive B allele at that locus, thus resulting in no striped cats. When the A allele is homozygous recessive at the A locus, the rest of the pathway is inhibited due to the epistatic nature of the locus, and only patternless offspring are created. Once again, the alleles of the B locus do not matter, as the A is epistatic when expression of enzyme A is inhibited. We observed 8 cats that exhibited patternless fur, which is twice as large as the amount we observed when performing our standard dihybrid cross.